All right. So I wanted to continue working on the section 2.1 guided notes. We were just working on using function notation and trying to evaluate functions. So I just wanted to start there with question number 9. All right, so if you're asked to find f of 3, because it said f, we would go to the rule 2x plus 5. F of x equals 2x plus 5. And 3 is your input, so that's your x. So you're going to plug it in place of the x and then work that out, and you'll get 6 plus 5, which is 11. All right, do the same thing if I want f of negative 4. So in place of x, I put negative 4. Then I do 2 times negative 4, which is negative 8. And when I add 5, I wind up with negative 3. So your answer to these questions would be the y values that are matched up with the x's that you started with. So these are your outputs. These are your y's here. All right, so if f of 3 equals 11, it's like it's telling you that when x is 3, y is 11. It's like it's giving you an ordered pair, okay? You're finding the output matching up with an input of 3, okay? All right, so let's go ahead and think about this when what we're inputting is not a number, but maybe a variable or a variable expression. All right, this is still our input here, okay? And the rule says take 2 times your input and add 5, so we'd wind up with 2a plus 5, but that's as far as we can go. We can't simplify anymore, and our answer would be 2a plus 5, and we'd be done. Okay? Now, if I asked for f of, and inside the parentheses was x minus 1, then all of that is my input. And so I would do 2 times my input and then add 5. And on this one, I could simplify a little bit by distributing the 2. So I'd get 2x minus 2. And then combining my like terms, the negative 2 and the positive 5, would make it 2x plus 3. So what I'm coming up with is a new formula, a new rule. I don't get a number because I wasn't just putting a number in at the start. Okay? Now we did g, but I'm going to go ahead and do it again. So because it said g, I go to this description, this rule, and g says to take your input and square it, do minus 5 times your input and add 1. And then you can work that out. You can type that in and hit enter or work that out, and you'll get, let's see, 9 minus 15. That would be negative 6 plus 1. That would be a negative 5. Okay? All right, and then if I put in a negative 4, I'd have to square the negative 4, so make sure that's in parentheses. I talked about that there's a difference between these. You have to understand those don't say the same thing. This is negative 1 times 4 times 4. This is negative 4 times itself, right? So we get a negative 16 there and a positive 16 there. You have to really watch it. The calculator will do what you tell it to do. So make sure you have parentheses around that if you're using your calculator. All right, so this would be, if I'm doing it by hand, this would be positive 16. Then here I have a negative and a negative being multiplied. So that's plus 20 plus 1 more. That would turn out to be 37. My answer would be that y value that's associated with an x value of negative 4. All right, if I plug in a, I'm just going to replace the x with an a, and I just wind up with that rule. And that would be as good as it gets. Those aren't like terms that can be combined. And then if I put in x minus 1 everywhere, if that's my new input, I put it in place of my x. I'm going to square that, do minus 5 times my input plus 1. All right, these two right here can be confusing when you're new to function notation. It's like these rules that we had up here at the start. It's almost like instead you want to just kind of think about it like this, without an x really there. The x is like a placeholder, right? It's just saying f of your input is 2 times your input plus 5. So when you're replacing the x with x minus 1, think about it that way. you're going to square your input, then do -5 times your input plus 1. Now, we got to work that out and simplify that. So there's some basic algebra that you got to be reminded of. That x minus 1 squared, remember, is x minus 1 times itself. So when you work that out, you're actually going to get x squared minus 1x minus another 1x plus 1. There's a middle term in there. I'm going to go ahead and distribute the -5. I'll get a -5x plus 5 plus 1. Okay, so the first two, the x minus 1 squared, isn't just x squared plus 1 or x squared minus 1. It has a middle term, doesn't it? X squared minus 2x plus 1. Okay, now let's combine our like terms here. So we have x squared. These would combine to be minus 7x, and then 1, 5, and another 1 would be plus 7. And that would be our answer, okay? All right, so we're going to look some more at function notation, but we're going to look at how to interpret it when you're given a graph. So here I'm asked two questions. I have this graph that represents T cell count and HIV infection, and that's years after the infection was identified. All right, so find f of v. So that means find the T cell count 5 years after infection. Okay, so find the average T cell count. That's what I'm looking for. The 5 is the x, which would be the time after the infection. So I don't have a formula I can plug into. So what I'm going to do is go and identify the 5. I'm going to go until I hit the function. Then I'm going to go and estimate what I get there. So what I wind up with is 400. It's 400 T cells per milliliter of blood. Per milliliter of blood. So you do have to watch the units, but typically they'll just want the 400. Okay? Now this one is kind of the reverse question. It said, you know, when would the T cell count? See, this right here is years, isn't it? It's the time since the infection, because that's the input, that's the X value. Okay? This right here is saying that the output, see, this would be the output, is 100. This is the output, which is the T cell count per milliliter of blood. Okay? See, they're giving you the output and asking you for the input. Okay? So what we would do there would be to think about where 100, the T cell count per milliliter, where the T cell count would be 100. So I'm going to look at this, and it might hit the graph in more than one spot, but in this case it doesn't. It appears to hit it around 9, it looks like. So the value, it would just be at that one spot, so it would be when X is 9, or 9 years after the infection. Okay. Now, if that question had been, so what if it had been 600? You know, what if it had been, for what values of x is f of x equal to 600? Okay, then look what would happen. We'd be up here. Let me erase my other lines. We'd be thinking about being up here at 600. And you see, if we do that, there's really going to be 3 times when that appears to be the case. So we'd have whatever this time is, whatever that time is. These really should drop perfectly straight down to the x-axis. I just can't do it when I'm writing like this. And then about there. So it looks like, you know, a couple of times within the first year, and then again around 1.5 years. Okay. All right. Now let's just use some graphs that are out of context to do this a little bit more. All right, so here I'm looking for g of negative 2. Okay, so I'm going to do that one in blue, g of negative 2. So think about how negative 2 is your x value. So look for it on the x-axis. So here's negative 2. All right, now sometimes you have to go up, sometimes you have to go down. You just have to hit the graph that represents the function. Okay, so I would hit the graph by going up. Then I would go over to the y-axis so that I could identify what's the y-coordinate matched up with that. So g of negative 2 looks like it would equal 1. Okay? We don't have a rule we can plug into, so we're estimating from the graph. Now, they're asking me for g of 10. The 10 would be the x. The reason they're doing that, even though my graph doesn't do that, is it looks like what they're conveying here is that this would just keep going, wouldn't it? So even when I'm way out here at 4, 5, 6, 7, 8, 9, way out here, I would go here to hit the function, and then do you see how that would be a y value of negative 2? So it looks like from an x value of 2 on, an x value of 2 or 3 or 4, you're going to hit the function, you're going to go to a negative 2 on the y. Okay? Now, if I want to know for what values of x is g of x equal to negative 1, the negative 1 is a y. Okay, so let me clear what I've written before off. So that means I would think about being here at a y of negative 1. In this case, it hits the function in just one spot. And the x that it is connected to is an x of 1. So g of x equals negative 1 when x equals 1. Okay, so you would answer it with 1. Okay. Now, there's some special points on graphs that we are sometimes asked for, so I wanted to comment on that. So an x-intercept is a point which crosses the x-axis. So you might have a function, it may do all sorts of crazy things, so let's suppose this one does something like that. Okay, an x-intercept would be where it crosses the x-axis. Notice this particular sketch I just drew would have 2 of them. Those would be x-intercepts. Okay? And then a y-intercept is a point at which the graph crosses the y-axis. So that would be right there. Okay, that would be a y-intercept. Okay? So you may not have any intercepts. Okay? And then with x-intercepts, you might have more than one. But if you have a function, you can only have one y-intercept. Can you think about why that would be? How come you could only have one point on the y-axis if you have a function? Can you picture that? See, if you had another point on the y-axis and your function did something like that, then it's not really a function, right? Because it couldn't be a function. It would have 2 outputs for 1 input. Okay? So why can it only have at most one y-intercept? Is because otherwise it wouldn't pass the vertical line test. Okay. All right, so you might have questions that ask for the x and the y-intercept, and I forgot to go into MyLab and Mastering to see which way they like these to be reported. Mathematically or technically, you can report them just with a number. Like, for instance, the x-intercepts would be these guys where it crosses the x-axis. So it'd be okay to say at -3 and at 2, there'd be 2 x-intercepts. But they really are points, so sometimes we like people to write them as ordered pairs. Okay, and I didn't check it before I started the video, but I believe they'd like it just like this, just the x value. So just the -3 and the 2. Okay, but both would have been actually correct. Okay. Now the y-intercept would be where it crosses the y-axis. So you see that would be here at -6. It's also a point, but if you labeled the coordinates of that point, the 0 would be in the first spot. But I believe they want it just with the number -6 with my math lab. Okay. All right, so x-intercepts, where it crosses the x-axis. So those are your x-intercepts. In this case, there's more than one. And then your y-intercept would be where it crosses the y-axis. And these are sometimes, some textbooks, some teachers, they'll report them as just the number, but sometimes they report them as an ordered pair. And these are special. These are points that have a 0 for one of the coordinates, but you have to get it straight. So think about plotting those. This point right here, you would go 2 to the right and then stay there. This point would be -3 to the left and then stay there. And then this point right here, you wouldn't go left or right, but then you'd go down 6. All right, but again, in my lab and mastering, I believe they ask you just to report the numbers, the -3 and the 2. Okay, and then for the y-intercept, the -6. All right, then there's going to be some problems where they ask you to take a graph and do a whole bunch of things. Okay, so this one's asking for the domain. They'll want those in interval notation. Notice these arrows right here mean that this graph continues, keeps going out a little bit, and it goes on forever. So ultimately, you could find x's anywhere from -infinity to +infinity. It's nice and continuous, and this keeps going out. So even if I were out at -1 million, if I went far enough down, I'd be able to find a y-coordinate matched up with it. Now for the range, the domain is from left to right, leftmost to rightmost. For the range, okay, it would be from the bottom to the top, lowest to highest, okay, from the bottom to the top. So with those arrows continuing on down, you would have y values from anywhere from -infinity, but then do you see how it would stop right here? There's no points above that point right there. So it would stop at 4, and you typically assume that that point is included and do a bracket, but technically you're just estimating that from the graph. Okay, the x-intercept, would be where it crosses the x-axis. So you would say at -3 and at 1, and that's not an ordered pair. I think it asks you to put commas between them in my lab and mastering. You're really saying the point -30 and the point 10. Okay, you have y-intercepts. The y-intercept would be right there where the graph crosses the y-axis, which is at 3. And if you wrote it as an ordered pair, it would be 0, 3. But my lab and mastering, I believe, just ask you to report the 3. Okay? Now back to what we did earlier. F of -2. F of -2. -2 is an x, so you should go to a -2 on the x. Whether you go up or down depends on the graph of the function. You're looking for a point that has an x of -2. Okay? So I'm going to need to go till I hit the function, which would be up in this case. That would be a point that has an x of -2, and then you can look over to the right to find the y-coordinate. See, that point would be -2, 3. So f of -2 would be 3. And then when they ask you for the values of x, if they were to ask you for the values of x, where f of x equals 0, that's when you should think, if f of x equals 0, that means y equals 0. Let me make that a little skinnier. Okay, well, y equals 0 anytime I'm on the x-axis. So here's a point where y equals 0 on the function, and here's a point on the function where y equals 0. So it would turn out to be -3 and also 1. Not a point, but two separate x values. So x equals -3 or x equals 1. All right, I wanted to do several examples of this because this, trying to interpret graphs can be a challenge when you're first trying to do this. All right, let's look at this guy. Number 14, there's our graph. Notice the open and the closed circles on the ends, but nice and continuous in between. All right, domain. Domain should be x's. Okay, so let's pretend that I've painted this green. Right, painted this green. If I want the x's, want the domain, I should be thinking x's. So if I were to project all those points to the x-axis, right, I would be covering up everything from there to there. So that would be from -6 to 0. Now, what I would put on either end, the -6 had an open circle, so I'd put a parenthesis. Right here, I have a closed dot, so I'd put a bracket. So we're saying all the numbers from -6 to 0, including the 0. Okay, that's domain. For range, let's color it in blue. Let's paint it blue. Let me just get rid of this other stuff. I'm going to paint it blue. Okay. Open at this end, closed at that, but I'm looking for the y coordinates, right? The y's for the range. So that means I'd be there, 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 there. And what would be covered up on the y-axis, remember to do bottom to top, would be from -3 to 4. But -3 had a closed dot, and when I was at 4, that came from this point, which had an open circle. So I would use a parenthesis on that. Okay. Now for x-intercepts, I need to look at this more carefully. Let me erase that so I can see it. For x-intercepts, I'm just looking for where does it cross the x-axis. That would be at -4. For y-intercepts, I'm looking for where it crosses the y-axis. That would be here at -3. It was a closed dot, so that's why I can say -3. If it had been an open circle at -3, I would have had to say there's no y-intercept. Okay. And then f of -4 means if x were -4, what would be the y matched up with it? So I'd go to -4, and I'm right there. And the y matched up with that is 0. So f of -4 would be 0. Okay? All right, let's try 15. Use the graph to find the following. Oh, this is an interesting one. This is the first one we've encountered where the function is not continuous. There's just discrete points. You have discrete points. So this one, I'm not going to have an interval. I'm going to have individual numbers. So the domain would be the x's of these ordered pairs that you see, right? What the x coordinates are. So if I start with this first point over here on the left, isn't the x a -5? Then this second point, the x is a -2. This one right here on that y-axis, that one is an x of 0. And then I have a point with an x of 1 and then a point with an x of 4. Okay? Now range are the y-coordinates. So notice the y-coordinate of this point way over here is down at -2, and that's true for this point, this point, this point, this point. All of the y-coordinates are just -2. Okay? All right, now x-intercepts. I don't see where the function, there's no points on the x-axis. The function doesn't cross the x-axis, so there are none. And then for the y-intercept, I do have a point right here that's on the y-axis. That's a y-intercept, and you would say you have a y-intercept at -2. If you were to write it as an ordered pair, it would be 0, -2. All right. And then the next question is asking you to take f of -5 and add f of 4. So f of -5, y value matched up with an x of -5. So here's an x of -5. That would be this point, which has a y coordinate of -2. Okay? F of 4. F of 4. What's the output matched up with an input of 4? 4 is your x. That means you're looking at that point. And the y value is -2. And then I'm supposed to add those. And a -2 plus a -2 would be -4. So that would be my answer.